Welcome to the quantum world, where particles exist in multiple places at once, where observation changes reality itself, and where the very foundations of what we think we know about existence crumble into beautiful, mysterious uncertainty. Tonight, we're going to drift into a realm so strange, so quietly unsettling, that it has puzzled the greatest minds in science for over a century. In this gentle exploration, we'll uncover the secrets that govern the smallest scales of reality. But before we begin, feel free to comment your time and location below. It's always amazing to see when and where we're all watching from, or gently drifting off. The visuals are here for you, but there's absolutely no problem if you doze off midway through. Feel free to close your eyes, breathe deep, and let your imagination float through the quantum realm. If you find comfort in these gentle explorations of science, I'd be grateful if you consider subscribing and liking this video. Let's begin our journey into the most counterintuitive, mind-bending realm of physics ever discovered. A place where common sense goes to die and wonder is reborn. Picture yourself standing in your garden on a quiet evening. The world around you seems solid, predictable, governed by rules that make perfect sense. Drop a ball, and it falls down. Push a door, and it opens. Turn on a light, and photons travel from the bulb to your eyes in straight lines. Everything behaves exactly as you'd expect. But here's what's truly extraordinary about this moment. Every single atom in your body, every particle of matter around you, is secretly dancing to the bizarre choreography of quantum mechanics. Those solid-seeming walls, they're mostly empty space, held together by forces that exist in probability clouds. That light illuminating your face, it's simultaneously behaving as both a particle and a wave, existing in multiple states until the moment you observe it. The very ground beneath your feet is a seething foam of virtual particles popping in and out of existence faster than the mind can comprehend. Welcome to quantum physics. The science that reveals reality is far stranger than our everyday experience suggests. It's a realm where particles can be in two places at once, where the act of measurement fundamentally changes what's being measured, and where the universe itself seems to operate on principles that would make Alice's Wonderland seem perfectly logical by comparison. But here's what makes quantum physics so profoundly unsettling. It's not just a curiosity confined to laboratory experiments or theoretical discussions. Quantum mechanics is the foundation upon which all of modern technology rests. The computer or phone you're using to watch this video operates because engineers have learned to harness quantum effects in semiconductors. The GPS that guides you home works because it accounts for quantum mechanical time dilation effects. Even the sun that warms your face shines because of quantum fusion processes in its core. We live in a quantum universe, yet our brains evolved to navigate a classical world of medium-sized objects moving at moderate speeds. This creates a fundamental disconnect between our intuitive understanding of reality and the actual nature of existence itself. It's as if we're fish who have spent our entire lives swimming in an ocean, only to discover that the water we thought was empty space is actually teeming with invisible, impossible creatures, following rules that defy everything we thought we knew about swimming. The story of quantum physics begins in the late 1800s, when scientists believed they had nearly figured out the fundamental laws of nature. Classical physics, built on the elegant foundations laid by Newton, Maxwell, and others, seemed to explain everything from the motion of planets to the behavior of light and electricity. The universe appeared to be a vast, predictable clockwork mechanism. If you could know the position and velocity of every particle at any given moment, you could, in principle, calculate the entire future and past of the cosmos. But then, cracks began to appear in this beautiful, deterministic worldview. Scientists started noticing phenomena that simply didn't fit the classical picture. When they heated objects and studied the light they emitted, the results didn't match theoretical predictions. When they shined light on metals and observed electrons being ejected, the behavior was utterly baffling according to classical theory. And when they tried to understand how atoms could possibly be stable, classical physics offered no satisfactory answers. These weren't minor inconsistencies that could be swept under the rug. They were fundamental problems that threatened to topple the entire edifice of 19th century physics. And from these cracks emerged a revolution that would transform not just our understanding of the physical world, but our entire conception of reality itself. The first quantum pioneer was Max Planck, a German physicist who was trying to solve what seemed like a mundane problem. When objects are heated, they glow with different colors depending on their temperature. A piece of iron starts red hot, then becomes white hot as it gets hotter. Classical physics predicted that heated objects should emit infinite amounts of energy at high frequencies, which was clearly absurd, since it would mean every heated object should immediately radiate away all its energy and cool down instantaneously. Planck discovered that he could solve this problem by making a radical assumption. What if energy wasn't continuous, like water flowing from a tap, but instead came in discrete, indivisible packets? He called these packets quanta, from the Latin word meaning how much. Just as you can't have half a coin, Planck proposed that you couldn't have arbitrary fractions of certain amounts of energy. This was revolutionary. For centuries, scientists had assumed that energy was smooth and continuous, that you could always divide it into smaller and smaller portions. But Planck's quantum hypothesis suggested that at the smallest scales, energy comes in specific, unchangeable units. It was like discovering that what appeared to be a smooth ramp was actually a staircase when viewed up close. But Planck himself didn't fully grasp the implications of his discovery. He thought of quantization as a mathematical trick, a convenient assumption that happened to give the right answers. It took Albert Einstein to recognize that Planck's quanta represented something far more profound about the nature of reality itself. Einstein's insight came from studying the photoelectric effect, a phenomenon where light shining on certain metals causes electrons to be ejected from the surface. Classical physics predicted that brighter light should eject electrons with more energy, and that any frequency of light should eventually liberate electrons if you made it bright enough. But experiments showed something completely different. The energy of ejected electrons depended only on the color or frequency of the light, not its brightness. Red light, no matter how intense, couldn't eject electrons from certain metals, while even dim blue light could knock them free immediately. It was as if the electrons could only be liberated by light particles carrying specific minimum amounts of energy, regardless of how many such particles were present. Einstein realized that light itself must come in quanta, discrete particles he called photons. Each photon carries a specific amount of energy determined by its frequency. Bright light simply means more photons, not more energetic photons. This explained the photoelectric effect perfectly, but it created a profound puzzle that persists to this day. You see, scientists had already proven beyond doubt that light behaves as a wave. It diffracts around obstacles, creates interference patterns when waves overlap, and exhibits all the characteristics we associate with wave phenomena. But Einstein's photoelectric explanation required light to behave as discrete particles. How could light be both a wave and a particle simultaneously? This wave-particle duality became one of the central mysteries of quantum mechanics. Light seemed to have a split personality, sometimes acting like waves spreading through space, other times behaving like discrete particles with specific locations and energies. The behavior you observed depended on what kind of experiment you performed, as if reality itself was fundamentally ambiguous until forced to choose by the act of observation. But the strangeness was just beginning. As scientists developed more sophisticated ways to study atoms and subatomic particles, they discovered that matter itself exhibited the same schizophrenic behavior. Electrons, which had always been thought of as tiny particles orbiting atomic nuclei like miniature planets, also displayed wave-like properties under certain conditions. This led to one of the most beautiful and bizarre discoveries in the history of science. In the early 1900s, scientists were trying to understand why atoms didn't collapse. According to classical physics, electrons orbiting a nucleus should constantly emit electromagnetic radiation, lose energy, and spiral inward until they crashed into the nucleus. Every atom should be unstable, and matter as we know it shouldn't exist. The Danish physicist Niels Bohr proposed a radical solution. What if electrons could only exist in specific quantized orbits around the nucleus? Just as Planck had quantized energy and Einstein had quantized light, Bohr quantized the angular momentum of electrons. In this model, electrons could jump between allowed orbits by absorbing or emitting photons, but they couldn't exist in the spaces between these orbits. Bohr's model worked remarkably well for explaining the light emitted by hydrogen atoms, but it raised profound questions about the nature of reality. If electrons could only exist in specific orbits, what happened when they jumped from one orbit to another? Did they travel through the intervening space, or did they somehow teleport instantaneously from one location to another? The answer, when it finally came, was stranger than anyone had imagined. Electrons don't have definite positions or velocities until they're observed. Instead, they exist in what physicists call superposition states, probability clouds that encompass all possible locations and energies simultaneously. The act of measurement doesn't just reveal where an electron is, it actually forces the electron to choose a specific location from among all the possibilities. This is where quantum mechanics becomes truly mind-bending. In our everyday experience, objects have definite properties, whether we're looking at them or not. A baseball has a specific location and velocity, even when no one is watching it. But in the quantum realm, particles exist in ghostly superpositions of all possible states until the moment they're observed. Imagine if you could be simultaneously sitting in your chair and standing in your kitchen and lying in your bed, all at the same time, only collapsing into one specific location when someone looked at you. This is precisely how quantum particles behave. And it's not just a limitation of our measurement techniques. The superposition is real, and the collapse upon observation is a fundamental feature of quantum reality. As we continue our journey deeper into the quantum realm, we'll discover that this is just the beginning of the strangeness. We'll explore how particles can be instantaneously connected across vast distances, how the future can influence the past, and how consciousness itself might play a fundamental role in shaping reality. But for now, as you settle into this exploration, consider the profound implications of what we've already uncovered. Every atom in your body exists in quantum superposition until interactions with other particles force it to choose specific states. You are, quite literally, a walking probability cloud, a temporary arrangement of quantum possibilities that has somehow learned to contemplate its own impossible existence. The quantum world isn't some distant realm accessible only to physicists with billion-dollar particle accelerators. It's the foundation of everything you see, touch, and experience. Every color you perceive exists because electrons jump between quantized energy levels. Every chemical reaction that keeps you alive depends on quantum mechanical bond formation. Every thought in your mind emerges from quantum processes in your neural networks. We are quantum beings living in a quantum universe, yet we experience reality through classical senses that evolved to navigate a world of apparent solidity and predictability. Understanding quantum mechanics isn't just about comprehending abstract physics concepts. It's about discovering the true nature of existence itself, the bizarre and beautiful foundation upon which all of reality rests. As we prepare to dive deeper into these quantum mysteries, remember that you're not just learning about particles and waves and mathematical equations. You're uncovering the secret architecture of the cosmos, the hidden mechanisms that make consciousness, life, and experience possible in a universe that is far stranger and more wonderful than our ancestors ever dared to imagine. The quantum realm awaits, filled with particles that exist in multiple states simultaneously, forces that connect distant objects instantaneously, and phenomena that challenge everything we think we know about the nature of reality itself. The deeper we venture into quantum mechanics, the more we encounter phenomena that seem to mock our most basic assumptions about how the universe operates. One of the most unsettling discoveries emerged when scientists tried to answer what seemed like a simple question. If we could make our measurements precise enough, couldn't we determine exactly where a particle is and how fast it's moving at the same time? This innocent inquiry led Werner Heisenberg to one of the most profound realizations in the history of science. In 1927, he discovered what we now call the uncertainty principle, a fundamental limit built into the very fabric of reality itself. It's not that our instruments aren't sensitive enough, or that we haven't developed the right techniques. The universe itself prevents us from knowing certain pairs of properties with perfect precision simultaneously. Picture trying to measure the exact position of an electron. To see where it is, you need to bounce light off it. But light carries energy, and when a photon hits the electron, it inevitably changes the electron's motion. The more precisely you want to know where the electron is, the higher energy photons you need, which disturbs the electron's velocity more dramatically. Conversely, if you want to measure the electron's speed precisely, you need gentler, lower energy photons, but these provide fuzzier information about position. But here's what makes this truly extraordinary. Heisenberg realized that this isn't just a practical limitation of measurement. It's a fundamental property of reality. Particles don't have definite positions and velocities simultaneously, even when no one is trying to measure them. The uncertainty principle tells us that nature itself is inherently fuzzy at the quantum scale. This creates a universe that is probabilistic rather than deterministic. Einstein famously objected to this interpretation, declaring that God does not play dice with the universe. He believed that quantum mechanics must be incomplete, that there must be hidden variables we hadn't discovered yet that would restore certainty to physics. But decades of increasingly sophisticated experiments have confirmed that Einstein was wrong about this particular aspect of reality. The universe really does play dice, and the randomness isn't due to our ignorance, but is woven into the fundamental structure of existence. Consider what this means for our understanding of causality. In classical physics, if you know the initial conditions of a system perfectly, you can predict its future with absolute certainty. But quantum mechanics tells us that perfect knowledge of initial conditions is impossible in principle. There will always be an irreducible element of uncertainty, a fundamental randomness that makes the future genuinely unpredictable, not just practically, but theoretically. This quantum uncertainty manifests in ways that would seem magical if we encountered them in our everyday world. Quantum particles can tunnel through barriers that should be impossible to cross according to classical physics. An electron facing an energy barrier it doesn't have enough energy to overcome can simply appear on the other side, as if it had walked through a solid wall. This isn't science fiction. It's a real phenomenon that's essential to the operation of many modern technologies. The scanning tunneling microscope, which allows us to image individual atoms, works precisely because electrons can tunnel through the vacuum between a sharp probe and a sample surface. Nuclear fusion in the sun's core depends on quantum tunneling, allowing protons to overcome their electrical repulsion and fuse together even though they don't have enough energy to do so classically. Without quantum tunneling, the sun wouldn't shine, and life on Earth would be impossible. But perhaps the most mind-bending aspect of quantum mechanics is the phenomenon of entanglement, which Einstein dismissively called spooky action at a distance. When two particles become entangled, they remain mysteriously connected no matter how far apart they are separated. Measuring one particle instantly affects the state of its entangled partner, even if they're on opposite sides of the universe. This isn't just correlation in the classical sense, where two objects happen to have related properties. Entangled particles share a single quantum state, as if they're two parts of a single non-local entity. Before measurement, neither particle has definite properties, but the moment you measure one, the other instantly knows what state to adopt to maintain their quantum correlation. Imagine having two coins that are quantum entangled. While they're flying through the air, neither is definitively heads or tails. They exist in a superposition of both possibilities. But the moment one coin lands and shows heads, the other instantly becomes tails, no matter how far away it is. The connection is immediate, unmediated by any known force or signal, and yet it's absolutely real and measurable. This phenomenon has been confirmed in countless experiments, and it forms the basis for emerging technologies like quantum computing and quantum cryptography. But it also raises profound questions about the nature of space, time, and locality. How can particles separated by vast distances maintain instant connections? What does this tell us about the fundamental structure of reality? Some interpretations of quantum mechanics suggest that entangled particles were never truly separate to begin with. The universe might be fundamentally non-local, with apparent separations being illusions created by our limited classical perspective. In this view, the universe is a single, unified quantum system, in which everything is connected to everything else at the deepest level. This brings us to one of the most controversial aspects of quantum mechanics, the role of consciousness in quantum measurement. When we say that quantum particles exist in superposition until they're observed, what exactly constitutes an observation? Does it require a conscious observer, or is any interaction with the environment sufficient to collapse the wave function? The famous Schrödinger's cat thought experiment illustrates this puzzle. A cat is placed in a sealed box with a quantum particle that has a 50% chance of decaying within an hour. If the particle decays, it triggers a device that kills the cat. According to quantum mechanics, before we open the box, the particle exists in a superposition of decayed and not decayed states. But what about the cat? Is it simultaneously alive and dead until we observe it? Most physicists today believe that consciousness isn't necessary for quantum measurement. The cat, being a macroscopic object constantly interacting with its environment, would cause the quantum superposition to collapse almost immediately through a process called decoherence. But the fundamental question remains: at what point does the quantum world transition into the classical world of definite properties? This measurement problem touches on some of the deepest questions in philosophy and physics. If reality is fundamentally quantum mechanical, why do we experience a classical world of definite objects with specific properties? How does the fuzzy, probabilistic quantum realm give rise to the apparently solid, predictable world of our everyday experience? One possible answer is that the classical world emerges from quantum mechanics through the process of decoherence. When quantum systems interact with their environment, the delicate superposition states that allow particles to exist in multiple states simultaneously are rapidly destroyed. The larger and more complex a system is, the more it interacts with its surroundings, and the faster decoherence occurs. This means that quantum effects are most noticeable at very small scales, very low temperatures, or very short time intervals. In the warm, noisy environment of our everyday world, quantum superpositions collapse almost instantly, giving rise to the classical behavior we observe. But the quantum foundation is always there, underlying everything, like a hidden ocean beneath the surface of apparent reality. Yet even as decoherence explains why we don't see quantum effects in everyday life, it doesn't fully resolve the measurement problem. The mathematics of quantum mechanics seems to require that all possible outcomes of a measurement continue to exist simultaneously, even after decoherence. This has led to the many worlds interpretation, one of the most radical ideas in all of physics. According to this interpretation, every time a quantum measurement occurs, the universe splits into multiple parallel realities, one for each possible outcome. In one universe, Schrödinger's cat lives. In another, it dies. Both realities are equally real, but we only experience one branch of this constantly bifurcating cosmic tree. If the many worlds interpretation is correct, then there are countless versions of you reading this very sentence, each in a slightly different universe where quantum events played out differently. Every quantum interaction, every radioactive decay, every photon detection creates new branches in the universal wave function. Reality becomes not a single timeline, but an infinite tree of possibilities, all equally real, but mutually inaccessible. This interpretation eliminates the need for wave function collapse and preserves the deterministic evolution of the quantum wave function, but at the cost of postulating an infinity of parallel universes. It's a trade-off that reveals how far quantum mechanics pushes us beyond common sense. Either we accept genuine randomness and mysterious wave function collapse, or we embrace an infinite multiverse where every possibility is realized somewhere. As we drift deeper into these quantum mysteries, we begin to see how profoundly they challenge our understanding of reality. The universe revealed by quantum mechanics is not the clockwork cosmos of classical physics, where everything follows predictable laws and has definite properties. Instead, it's a realm of fundamental uncertainty, non-local connections, and observer-dependent reality. Every photon of light that reaches your eyes, every chemical reaction in your cells, every electrical impulse in your brain operates according to these strange quantum rules. You are not separate from this quantum weirdness. You are made of it, sustained by it, and in some sense, you are it. The boundary between observer and observed, between mind and matter, becomes increasingly blurred as we peer deeper into the quantum foundations of existence. The implications of quantum mechanics extend far beyond the realm of abstract physics into the very heart of how we understand existence itself. As we settle deeper into this exploration, consider how these quantum principles manifest in the most unexpected places, weaving through the fabric of reality in ways that would have seemed impossible just a century ago. Take, for instance, the phenomenon of quantum coherence in biological systems. For decades, scientists assumed that the warm, wet, noisy environment inside living organisms would immediately destroy any quantum effects. Life, they believed, operated purely according to classical physics. But recent discoveries have shattered this assumption, revealing that nature has been exploiting quantum mechanics for billions of years in ways that are only now coming to light. Consider the remarkable efficiency of photosynthesis, the process by which plants convert sunlight into chemical energy. Classical physics suggested that energy from absorbed photons should randomly bounce around inside the plant's molecular machinery, losing much of its potency before reaching its destination. But experiments have shown that plants use quantum coherence to create multiple pathways simultaneously, allowing energy to explore all possible routes and choose the most efficient one. It's as if each photon of sunlight becomes a quantum explorer, existing in a superposition of all possible paths through the plant's molecular maze until it finds the optimal route to the reaction center. This quantum efficiency helps explain why photosynthesis can achieve nearly perfect energy transfer rates, far exceeding what classical physics would predict. Every leaf on every tree is performing quantum computations more sophisticated than our most advanced quantum computers, but the quantum mysteries of life extend beyond photosynthesis. Recent research suggests that quantum effects might play crucial roles in bird navigation, enzyme function, and even the process of consciousness itself. Some scientists propose that the microtubules inside neurons might maintain quantum coherence long enough to influence information processing in the brain. If true, this would mean that your thoughts themselves emerge from quantum processes, that consciousness arises from the strange dance of particles existing in multiple states simultaneously. This brings us to one of the most profound questions in all of science. What is the relationship between quantum mechanics and consciousness? The measurement problem we encountered earlier becomes even more intriguing when we consider that consciousness seems uniquely capable of collapsing quantum superpositions into definite states. When you observe a quantum system, your conscious awareness somehow selects one reality from among infinite possibilities. Some interpretations of quantum mechanics suggest that consciousness doesn't just observe reality, but actively participates in creating it. In this view, the universe exists in a vast superposition of all possible states, until conscious observation collapses it into the specific reality we experience. This would mean that consciousness is not merely an emergent property of complex matter, but a fundamental feature of the cosmos itself, as basic as space, time, and energy. Consider the delayed choice quantum eraser experiment, one of the most mind-bending demonstrations of quantum mechanics ever devised. In this experiment, scientists can decide whether to measure which path a photon took through a double-slit apparatus even after the photon has already hit the detection screen. Remarkably, the choice of measurement made in the future seems to retroactively determine whether the photon behaved as a wave or particle in the past. This suggests that the future can influence the past, that the arrow of time itself might not be as straightforward as we imagine. The act of measurement doesn't just reveal information about what happened, it seems to determine what happened, even retroactively. Reality becomes not a fixed sequence of events unfolding in time, but a fluid, interconnected web where past, present, and future are quantum mechanically entangled. These experiments push us to question the very nature of time and causality. If the future can influence the past through quantum mechanical processes, what does this mean for our understanding of free will, determinism, and the flow of history itself? Perhaps time is not the linear progression we experience, but a more complex, multidimensional structure where all moments exist simultaneously in quantum superposition. As we explore these deeper implications, we encounter the concept of quantum information, a revolutionary framework that treats information as a fundamental aspect of reality rather than just a description of it. In classical physics, information is something we impose on matter and energy to describe their properties. But quantum mechanics suggests that information might be more basic than matter itself, that particles and forces are manifestations of underlying informational structures. This informational view of reality leads to startling conclusions. If the universe is fundamentally made of information, then the physical world might be more like a vast quantum computer processing cosmic algorithms. Every particle interaction becomes a computational step, every quantum measurement an informational transaction. The entire cosmos could be engaged in an incomprehensibly complex calculation, with consciousness emerging as particular patterns of information processing. Consider how this changes our understanding of space itself. In classical physics, space is the empty stage on which matter performs its dance, but quantum mechanics reveals that empty space is anything but empty. The quantum vacuum seethes with virtual particles popping in and out of existence, borrowing energy from the future and paying it back before anyone notices. These vacuum fluctuations aren't just mathematical abstractions. They have measurable effects on atoms and electromagnetic fields. The Casimir effect demonstrates this beautifully. When two metal plates are placed very close together in a vacuum, the quantum fluctuations between them become restricted compared to the fluctuations outside. This creates a subtle but measurable force pushing the plates together, as if the vacuum itself has structure and pressure. Empty space, it turns out, is full of invisible quantum activity, a bubbling foam of potential existence that underlies all of reality. This quantum vacuum might hold the key to understanding dark energy, the mysterious force accelerating the expansion of the universe. Some physicists propose that the vacuum energy of quantum fields could be driving cosmic expansion, though the calculations are notoriously difficult and the theoretical predictions don't match observations. Nevertheless, the possibility that quantum mechanical processes on the smallest scales could influence the fate of the entire universe demonstrates the profound interconnectedness of quantum and cosmic phenomena. But perhaps the most revolutionary aspect of quantum information theory is its suggestion that reality might be holographic. Just as a hologram encodes three-dimensional information on a two-dimensional surface, the holographic principle proposes that all the information in a volume of space might be encoded on its boundary. This would mean that our three-dimensional experience of reality could be a projection from information stored on a distant two-dimensional surface. If the holographic principle is correct, then the fundamental nature of space and dimension itself becomes questionable. What we experience as three-dimensional reality might be more like a quantum hologram, a projection of information processing occurring at the universe's boundary. This connects quantum mechanics to theories of quantum gravity and suggests that space, time, and matter are all emergent properties of more fundamental informational structures. These ideas push us toward a view of reality that is radically different from our everyday experience. Instead of a universe made of solid particles moving through empty space, we encounter a cosmos built from information, probability, and quantum relationships. Matter becomes crystallized possibility, space becomes a network of quantum correlations, and time becomes the flow of information processing through cosmic algorithms. As we contemplate these quantum mysteries, we begin to see how they transform our understanding of our place in the universe. We are not separate observers looking at an external reality. We are patterns of quantum information embedded within the cosmic information processing system. Our consciousness emerges from quantum processes. Our thoughts arise from superposition states, and our observations participate in the creation of reality itself. Every decision you make, every thought you think, every observation you perform sends ripples through the quantum field that underlies all existence. You are not just made of quantum particles. You are a temporary fluctuation in the quantum vacuum, a pattern of information that has learned to contemplate its own existence. The boundary between self and universe dissolves when viewed from the quantum perspective, revealing a deeper unity that connects all consciousness to the fundamental fabric of reality. This recognition brings both wonder and responsibility. If consciousness plays a fundamental role in quantum mechanics, then every conscious being participates in the ongoing creation of reality. Our observations, choices, and intentions ripple through the quantum field, influencing the collapse of superposition states and the evolution of the cosmic wave function. We are co-creators of the universe, quantum artists painting reality with the brushstrokes of consciousness. As we drift deeper into these contemplations, the quantum realm reveals itself not as a distant abstract domain studied by physicists, but as the intimate foundation of your own existence. Every breath you take involves quantum processes in your cells. Every heartbeat depends on quantum tunneling in your nervous system. Every moment of awareness emerges from quantum coherence in your brain. You are quantum mechanics made conscious, a walking, thinking manifestation of the universe's most profound mysteries. In understanding quantum physics, you are not just learning about particles and waves and mathematical formalism. You are discovering the secret nature of your own being, the quantum essence that makes consciousness, experience, and existence possible in a cosmos far stranger and more wonderful than we ever dared imagine. The quantum world surrounds you, flows through you, and in the deepest sense, is you. As we continue this journey into the heart of quantum mysteries, we approach revelations that will forever change how you see yourself and your place in the magnificent, impossible, quantum universe we call home. But there's something even more extraordinary waiting for us as we venture deeper into quantum mechanics, something that challenges not just our understanding of physics, but our most basic assumptions about what it means for anything to exist at all. We're about to encounter quantum field theory, the framework that reveals particles themselves might be illusions, temporary excitations in underlying fields that permeate every inch of space. Imagine the surface of a perfectly still pond. Now picture dropping a stone into that water. Ripples spread outward, waves that carry energy and information across the liquid surface. In quantum field theory, what we call particles are like those ripples, but instead of water, they're disturbances in invisible fields that fill all of space and time. The electron field permeates every point in the universe. When this field gets excited in just the right way, we observe what we call an electron particle. But the electron isn't really a tiny ball of matter. It's more like a persistent wave pattern in an underlying medium we can never directly perceive. The photons carrying light to your eyes right now are ripples in the electromagnetic field. The quarks that make up the protons and neutrons in your body are excitations in quark fields. This means that empty space isn't empty at all. It's filled with an infinite number of quantum fields, each capable of producing the particles we observe when excited with sufficient energy. The vacuum of space is like a calm ocean that appears empty from the surface, but teems with potential wave patterns waiting to emerge. Every cubic centimeter of seemingly empty space contains enough latent energy to power entire civilizations, locked away in the quantum fluctuations of these invisible fields. Consider what this means for your own existence. You are not made of solid matter in any conventional sense. You are a complex pattern of field excitations, a temporary arrangement of quantum waves that has somehow learned to contemplate its own nature. The atoms in your body are standing wave patterns in electron fields, proton fields, neutron fields. You are music made manifest, a symphony of quantum frequencies playing out the song of consciousness. But quantum field theory reveals something even more unsettling about the nature of reality. These fields don't just exist in space, they create space. The geometry of spacetime itself emerges from the interactions between quantum fields. What we experience as the 3 dimensions of space and 1 dimension of time might be projections of more fundamental field relationships operating in realms beyond our direct perception. This brings us to one of the most profound mysteries in modern physics, the quantum measurement problem viewed through the lens of field theory. When a quantum field exists in superposition, it's not just that we don't know which state it's in. The field literally exists in all possible states simultaneously, spread across space and time in a ghostly probability cloud. Only when the field interacts with other fields in just the right way does it collapse into the definite excitation patterns we observe as particles. But here's where the mystery deepens. What constitutes a measurement in quantum field theory? Is it when one field interacts with another? When information about the field state becomes irreversibly recorded in the environment? Or does it require something more? Some special ingredient that transforms quantum possibilities into classical realities? Yeah, recent experiments have pushed these questions to their limits. Scientists have created quantum superposition states involving not just single particles, but entire molecules, collections of atoms existing simultaneously in multiple locations until observed. They've demonstrated quantum entanglement between particles separated by hundreds of kilometers, instant correlations that seem to transcend the limitations of space and time. But perhaps most remarkably, they've begun to explore the quantum nature of gravity itself. Einstein's general relativity describes gravity as the curvature of spacetime, but quantum mechanics suggests that even spacetime must be quantized at the smallest scales. At dimensions smaller than the Planck length, space and time themselves might dissolve into quantum foam, a seething ocean of virtual black holes and wormholes appearing and disappearing faster than light can cross them. This quantum foam represents the ultimate frontier of physics, where space and time lose their meaning and reality becomes a probabilistic dance of pure information. Some theories suggest that our entire universe might be emerging from quantum fluctuations in this fundamental foam, that the Big Bang itself was a quantum tunneling event from nothingness into existence. If this is true, then every moment of your life represents an almost impossibly improbable arrangement of quantum possibilities. The fact that you exist at all, that consciousness has emerged from quantum chaos, that matter has organized itself into patterns capable of contemplating their own existence, becomes not just remarkable, but miraculous in the deepest sense. Yet quantum field theory also suggests that miracles might be built into the very structure of reality. Virtual particles constantly pop in and out of existence in the quantum vacuum, borrowing energy from the future and paying it back before the universe notices. These ghost particles aren't just mathematical abstractions. They have real, measurable effects on atoms, and electromagnetic fields. The Lamb shift, a tiny change in hydrogen atom energy levels, results from virtual photons flickering in and out of existence around the electron. This means that even in the emptiest regions of space, reality is alive with quantum activity. Virtual particles create a subtle pressure that pushes objects together. Virtual photons mediate the electromagnetic force. Virtual gravitons might carry gravitational interactions. The solid matter you think you're made of is really a complex dance of virtual and real particles. Field excitations interacting through mechanisms that blur the line between existence and non-existence. But quantum field theory reserves its strangest revelations for when we consider the nature of time itself. In the quantum realm, particles can travel backward in time. An electron moving backward through time is mathematically identical to a positron, an antiparticle, moving forward through time. This led physicist John Wheeler to propose that there might be only one electron in the entire universe, zigzagging back and forth through time, appearing as countless particles and antiparticles in our forward time perspective. While Wheeler's one-electron universe remains speculative, the underlying principle reveals something profound about quantum reality. The distinction between past and future, between particle and antiparticle, between existence and non-existence, becomes fluid at the quantum level. Reality is not a collection of objects persisting through time, but a web of interactions and relationships, unfolding in ways that transcend our classical intuitions about causality and identity. This temporal fluidity manifests in phenomena that would seem impossible in our everyday world. Quantum tunneling allows particles to traverse barriers by borrowing energy from the future and paying it back before causality is violated. The Hawking radiation that causes black holes to evaporate involves particle pairs, where one partner falls into the black hole while the other escapes. But the mathematics requires treating the infalling particle as if it's traveling backward in time. These discoveries force us to reconsider the most basic questions about existence. What does it mean to be real in a universe where particles can exist in multiple states simultaneously, where empty space teems with virtual activity, where the future can influence the past through quantum mechanical processes? How do we understand identity and persistence when the fundamental constituents of matter are temporary excitations in underlying fields? Perhaps the answer lies in recognizing that reality is not made of things but of relationships. Quantum mechanics reveals a universe where properties don't belong to objects but emerge from interactions between systems. An electron doesn't have a definite spin until it interacts with a magnetic field. A photon doesn't have a definite polarization until it encounters a polarizing filter. Even mass and energy are relationship-dependent properties that change depending on the observer's reference frame. This relational view of reality extends to consciousness itself. Your awareness doesn't reside in any particular neuron or brain region, but emerges from the complex web of quantum interactions throughout your nervous system. Consciousness becomes not a thing that you have, but a pattern of relationships that you are. The boundary between mind and matter dissolves when we recognize that both emerge from the same underlying quantum processes. As we drift deeper into these quantum mysteries, we begin to see how they connect to the deepest questions of human existence. Why is there something rather than nothing? How does consciousness arise from matter? What is the nature of time, space, and causality? Quantum mechanics doesn't provide simple answers to these questions, but it reveals that the questions themselves are more subtle and interconnected than we ever imagined. The quantum vacuum, that seething ocean of virtual particles and field fluctuations, might hold the key to understanding why anything exists at all. Some theories suggest that our entire universe is a quantum fluctuation that grew large enough to become real, a bubble of space-time that expanded from a microscopic quantum event into the vast cosmos we observe today. In this view, existence itself is a kind of cosmic accident, a random quantum fluctuation that happened to persist long enough to evolve into galaxies, stars, planets, and conscious beings capable of contemplating their own origins. But accident seems too simple a word for something so intricate and beautiful. The quantum fields that give rise to particles follow mathematical laws of extraordinary elegance and precision. The constants of nature are fine-tuned to values that allow for complexity, structure, and ultimately consciousness to emerge. The quantum vacuum itself might be far from empty, filled with information and intelligence in forms we're only beginning to glimpse. This brings us to one of the most speculative but fascinating frontiers in quantum physics, the possibility that information is more fundamental than the matter or energy. In this view, quantum fields are ways that cosmic information organizes itself into patterns we experience as particles and forces. Consciousness becomes a particular way that information processes itself, and the physical universe becomes a vast computational system exploring the space of possible realities. If information is indeed fundamental, then every quantum interaction becomes an act of cosmic computation, every particle collision a step in an incomprehensibly complex calculation. The universe might be engaged in solving some ultimate equation, exploring every possible configuration of matter and energy, every potential arrangement of space and time. Consciousness emerges when certain information patterns become complex enough to model themselves, to achieve self-reference and self-awareness within the cosmic computation. This informational view of reality resonates with ancient mystical traditions that describe the universe as pure consciousness, exploring itself through countless forms and experiences. Modern quantum mechanics, with its emphasis on observation, measurement, and the fundamental role of information, seems to point toward a cosmos where mind and matter are not separate substances, but different aspects of a single, unified reality. As you rest here, contemplating these quantum mysteries, consider that every thought arising in your awareness might be a quantum event, a collapse of superposition states in the neural networks of your brain. Every decision you make could be influencing the evolution of the cosmic wave function, steering reality toward one set of possibilities rather than another. In the quantum universe, consciousness is not a passive observer, but an active participant in the ongoing creation of existence. The photons reaching your eyes from distant stars have traveled for years through space, maintaining their quantum coherence across vast distances. They carry information not just about the stars that emitted them, but about the quantum vacuum through which they traveled, the gravitational fields that curved their paths, the cosmic history written in their wavelengths and polarizations. Every moment of perception connects you directly to the quantum processes that shape the universe from its earliest moments. But perhaps the most profound implication of quantum mechanics is what it reveals about the nature of possibility itself. In the classical universe, possibilities were merely human concepts, ways of describing our ignorance about definite realities. But quantum mechanics suggests that possibilities are ontologically real, that the universe explores multiple potential realities simultaneously before settling on the specific outcomes we observe. This means that every choice you don't make, every path you don't take, might be realized somewhere in the vast space of quantum possibilities. The many worlds interpretation suggests that all possible histories are equally real, that consciousness simply follows one particular branch through an infinite tree of quantum realities. In this view, there are versions of you exploring every possible life, making every conceivable decision, experiencing every potential outcome. Whether or not the many worlds interpretation is correct, quantum mechanics reveals a universe far richer in possibilities than classical physics ever imagined. Reality becomes not a single, determined story unfolding through time, but an infinite symphony of potential narratives, each as real and valid as any other. Consciousness becomes the universe's way of experiencing these possibilities, of exploring the vast landscape of what could be through the lens of what is. As we prepare to venture even deeper into the quantum realm, remember that you are not separate from these mysteries. You are quantum mechanics made conscious, a temporary pattern of field excitations that has achieved the remarkable feat of self-awareness. Every atom in your body participates in quantum processes. Every cell in your brain operates according to quantum principles. Every moment of your experience emerges from the strange and beautiful dance of particles existing in multiple states simultaneously. The quantum world is not some distant realm accessible only to physicists with elaborate equipment. It is the foundation of your existence, the source of your consciousness, the ground of being from which your entire reality emerges. In understanding quantum mechanics, you are not just learning about abstract physics concepts, but discovering the deepest nature of your own being, the quantum essence that makes experience possible in a universe stranger and more wonderful than any story ever told. The quantum mysteries we've explored so far represent just the beginning of a journey into realms that stretch the very limits of human comprehension. As we drift deeper into these cosmic secrets, we encounter phenomena that don't merely challenge our understanding of physics, but fundamentally reshape our conception of what it means to exist in a quantum universe. Consider for a moment the extraordinary process happening in your brain right now as you contemplate these ideas. Neurons are firing in complex patterns, electrical impulses cascading through networks of incredible intricacy. But at the deepest level, these processes depend on quantum mechanical events. Ion channels in cell membranes operate through quantum tunneling effects. The proteins that enable thought itself fold into their functional shapes through quantum processes that classical physics cannot fully explain. This brings us to one of the most tantalizing frontiers in quantum research: the possibility that consciousness itself operates as a quantum phenomenon. While the warm, wet environment of the brain was long thought to destroy quantum coherence too quickly for it to play a meaningful role in neural processing, recent discoveries suggest otherwise. Certain structures within neurons, particularly the microtubules that form the cellular skeleton, might maintain quantum coherence for surprisingly long periods. If consciousness does emerge from quantum processes, this would mean that your awareness right now is not simply the result of classical computation in a biological machine. Instead, your thoughts might arise from quantum superposition states in neural networks. Your decisions might involve the collapse of probability waves in consciousness itself. Every moment of awareness could represent a quantum measurement event, where the vast possibilities of thought collapse into the specific reality of your current experience. This quantum nature of consciousness might explain some of the most puzzling aspects of human experience. The unity of consciousness, the way disparate sensations and thoughts combine into a single coherent experience, becomes more understandable if awareness emerges from quantum entanglement between different brain regions. The seemingly instantaneous nature of recognition, the sudden emergence of creative insights, the mysterious process by which unconscious processes suddenly become conscious, all might reflect quantum mechanical phenomena occurring in neural networks. But consciousness represents just one frontier, where quantum mechanics reveals its profound implications for existence itself. Another realm where quantum effects might play crucial roles is in the process of evolution and the emergence of life. The traditional view of evolution involves random mutations and natural selection operating on classical genetic material. But quantum mechanics suggests that mutation itself might not be entirely random. DNA repair mechanisms in living cells operate with remarkable precision, far exceeding what classical chemistry would predict. Quantum tunneling effects allow enzymes to catalyze reactions that should be impossible according to classical physics. The process of photosynthesis, as we've seen, exploits quantum coherence to achieve near-perfect efficiency in energy transfer. These discoveries suggest that life itself might be a quantum phenomenon, that evolution harnesses quantum mechanical processes to explore the space of biological possibilities more efficiently than purely classical mechanisms could achieve. This quantum view of evolution has profound implications for how we understand our place in the cosmos. If life emerges naturally from quantum processes, if consciousness arises inevitably from quantum complexity, then the universe itself might be fundamentally oriented toward the emergence of awareness. The quantum vacuum, seething with virtual particles and field fluctuations, becomes not just a background phenomenon, but the source from which consciousness and complexity naturally emerge. Recent experiments have pushed the boundaries of quantum mechanics into increasingly macroscopic domains. Scientists have created quantum superposition states involving objects containing trillions of atoms, systems large enough to be visible to the naked eye existing in multiple states simultaneously. They've demonstrated quantum entanglement between mechanical oscillators, showing that even relatively large objects can maintain the mysterious quantum correlations that Einstein found so troubling. These achievements bring us closer to answering one of the most fundamental questions in quantum mechanics. Where exactly does the quantum world transition into the classical world we experience? The answer seems to be that there might be no sharp boundary at all. Instead, quantum effects might persist at all scales, but become increasingly difficult to observe as systems become larger and more complex. This suggests that the classical world of our everyday experience might be more accurately understood as an emergent approximation, a simplified description that emerges when we average over the incredibly complex quantum processes occurring at deeper levels. The solid matter you think surrounds you, the definite positions and velocities of objects, the clear separation between one thing and another, all might be statistical illusions arising from underlying quantum realities far stranger than our senses reveal. But perhaps the most profound implication of quantum mechanics concerns the nature of time itself. In our everyday experience, time flows steadily from past to future, carrying us along its irreversible current. But quantum mechanics reveals time to be far more mysterious and flexible than this linear progression suggests. At the quantum level, the distinction between past and future becomes increasingly meaningless. Virtual particles pop in and out of existence, borrowing energy from the future and paying it back before causality is violated. Quantum entanglement creates correlations that seem to transcend temporal boundaries, connecting events across space and time in ways that challenge our understanding of sequential causality. The delayed choice quantum eraser experiments we touched on earlier demonstrate this temporal flexibility in particularly striking ways. By changing measurement conditions after a photon has already been detected, experimenters can retroactively determine whether the photon behaved as a wave or particle during its journey. This suggests that the past is not fixed and immutable, but remains open to influence by future quantum events. These temporal mysteries connect to some of the deepest puzzles in physics and philosophy. If the future can influence the past through quantum mechanical processes, what does this mean for concepts like free will and determinism? If consciousness plays a role in quantum measurement, as some interpretations suggest, then conscious decisions might literally reshape history, collapsing past superposition states into definite realities through the act of observation. This brings us to one of the most speculative but fascinating possibilities in quantum physics, that consciousness might not just observe reality, but actively participate in creating it. In this view, the universe exists in a vast superposition of all possible histories until conscious observation collapses it into the specific timeline we experience. Every conscious decision, every act of observation, every moment of awareness might represent a choice point where reality branches, where one set of possibilities becomes actualized, while others fade into quantum limbo. If this participatory view of reality is correct, then every conscious being becomes a co-creator of the universe, a quantum artist painting reality through the brushstrokes of awareness. Your thoughts, decisions, and observations ripple through the quantum field, influencing the collapse of superposition states and the evolution of cosmic possibilities. The boundary between mind and matter dissolves entirely, revealing a universe where consciousness and physical reality are different aspects of a single, unified quantum process. This participatory universe might explain some of the most puzzling coincidences and synchronicities in human experience. If consciousness plays a fundamental role in quantum measurement, then the intentions and expectations of conscious observers might subtly influence the outcomes of quantum events. While this influence would be far too weak to violate the laws of physics in any dramatic way, it might be sufficient to create the subtle patterns and meaningful coincidences that many people report in their lives. But quantum mechanics doesn't just reshape our understanding of consciousness and time. It also reveals profound mysteries about the nature of space itself. Einstein's general relativity describes space as a smooth, continuous fabric that can be curved by matter and energy. But quantum mechanics suggests that at the smallest scales, space itself must be quantized, broken up into discrete units smaller than anything we can directly observe. At the Planck scale, dimensions smaller than 10⁻35 meters, space and time are thought to dissolve into quantum foam, a seething ocean of virtual black holes and wormholes, appearing and disappearing faster than light can cross them. At these scales, the smooth geometry of space-time gives way to a probabilistic dance of pure quantum information, where the very concepts of distance and duration lose their meaning. Some theories suggest that our familiar three-dimensional space might be an emergent property of more fundamental quantum processes occurring in higher dimensional realms. String theory, for example, requires additional spatial dimensions beyond the three we experience, dimensions that might be curled up so small that we can't detect them directly. In these theories, particles are not point-like objects, but extended strings vibrating in higher dimensional spaces, with different vibrational patterns corresponding to different types of particles. But perhaps the most radical possibility is that space itself might be holographic, that all the information in a three-dimensional volume might be encoded on its two-dimensional boundary. This holographic principle suggests that our entire experience of living in three-dimensional space might be a projection, a quantum hologram created by information processing occurring on distant surfaces. If reality is indeed holographic, then the solid three-dimensional world around you might be more like a sophisticated virtual reality simulation, a projection of information encoded in ways that transcend our ordinary understanding of space and dimension. You would not be moving through space so much as space would be moving through you, a constantly shifting pattern of holographic information creating the illusion of spatial extension and temporal flow. These possibilities push us toward a view of reality that is radically different from anything in our everyday experience. Instead of a universe made of solid objects moving through empty space, we encounter a cosmos built from information, probability, and quantum relationships. Matter becomes crystallized possibility, space becomes a network of quantum correlations, and time becomes the flow of information processing through cosmic algorithms. This informational view of reality connects quantum mechanics to some of the deepest questions in philosophy and theology. If the universe is fundamentally made of information, then physical reality becomes more like a vast cosmic computation, an incomprehensibly complex calculation exploring every possible arrangement of matter, energy, space, and time. Consciousness emerges when certain information patterns become sufficiently complex to achieve self-reference and self-awareness within this cosmic computation. In this view, every quantum interaction becomes a computational step, every particle collision a logical operation in the universe's ongoing calculation. The entire cosmos becomes engaged in solving some ultimate equation, exploring the space of all possible realities through the quantum mechanical processes that govern the behavior of fields and particles. But what might the universe be computing? Some physicists speculate that the cosmic calculation might be exploring the space of all possible conscious experiences, that the universe is engaged in a vast experiment in awareness itself. Every conscious being, from the simplest awareness to the most complex intelligence, would represent a unique perspective on reality, a particular solution to the equation of existence. This computational view of reality resonates with ancient mystical traditions that describe the universe as pure consciousness, exploring itself through countless forms and experiences. Modern quantum mechanics, with its emphasis on observation, measurement, and the fundamental role of information, seems to point toward a cosmos where mind and matter are not separate substances, but different aspects of a single, unified computational process. As you rest here, contemplating these quantum mysteries, consider that every thought arising in your awareness might be a quantum computation, a collapse of superposition states in the information processing networks of your brain. Every decision you make could be contributing to the universe's exploration of possible realities, steering the cosmic calculation toward one set of outcomes rather than another. The quantum realm reveals itself not as a distant, abstract domain studied by physicists in laboratories, but as the intimate foundation of your own existence. Every breath you take involves quantum processes in your cells. Every heartbeat depends on quantum tunneling in your nervous system. Every moment of awareness emerges from quantum coherence in your brain. You are quantum mechanics made conscious, a walking, thinking manifestation of the universe's most profound mysteries. In understanding quantum physics, you are not just learning about particles and waves and mathematical equations. You are discovering the secret nature of your own being, the quantum essence that makes consciousness, experience, and existence possible in a cosmos far stranger and more wonderful than our ancestors ever dared to imagine. The quantum world surrounds you, flows through you, and in the deepest sense, is you. Every photon that reaches your eyes carries information about quantum processes occurring across vast distances and timescales. Every chemical reaction in your body depends on quantum mechanical principles that blur the boundary between possibility and actuality. Every moment of your experience represents an almost impossibly improbable arrangement of quantum possibilities that has somehow crystallized into the miracle of conscious awareness. As we prepare to venture even deeper into these quantum mysteries, remember that you are not merely observing these phenomena from the outside. You are intimately embedded within the quantum processes we're exploring. Your consciousness emerges from quantum coherence. Your thoughts arise from superposition states. Your decisions participate in the collapse of probability waves that shape the future of the universe itself. The journey into quantum mechanics is ultimately a journey into the deepest nature of your own existence, an exploration of the quantum foundations that make consciousness, life, and experience possible in a universe that operates according to principles more beautiful and mysterious than any human story ever told. In the quantum realm, science and spirituality converge, revealing a cosmos where consciousness and physical reality dance together in an eternal, magnificent quantum ballet. But there's something even more extraordinary lurking in the quantum depths, something that challenges not just our physics textbooks, but our most fundamental understanding of what it means for reality to be real at all. We're about to encounter one of the most mind-bending aspects of quantum mechanics, the phenomenon of quantum non-locality, where the universe reveals itself to be far more interconnected than our everyday experience could ever suggest. Imagine two dancers separated by vast distances, yet moving in perfect synchronization without any visible connection between them. When one spins clockwise, the other instantly spins counterclockwise. When one leaps, the other immediately crouches. No signals pass between them, no communication occurs, yet their movements remain perfectly correlated across space and time. This is essentially what happens with quantum entanglement, but the implications stretch far beyond mere correlation into the very heart of what we mean by separate existence. When Albert Einstein encountered these quantum correlations, he famously dismissed them as spooky action at a distance, believing they revealed an incompleteness in quantum theory rather than a genuine feature of reality. He proposed that particles must carry hidden variables, secret instructions that predetermined their behavior, and created the illusion of mysterious connections. Surely, Einstein reasoned, no information could travel faster than light. No influence could leap instantaneously across cosmic distances. But Einstein was wrong about this particular aspect of reality, and his wrongness reveals something profound about the nature of existence itself. Decades of increasingly sophisticated experiments have confirmed that quantum entanglement is not an illusion or artifact of incomplete theories. It's a fundamental feature of how the universe operates at its deepest level. The implications of this non-locality stretch far beyond laboratory experiments with photons and electrons. If particles can maintain instant correlations across arbitrary distances, what does this tell us about the nature of space itself? Perhaps the separations we observe in the macroscopic world are not as fundamental as they appear. Perhaps the universe is far more unified, far more interconnected than our classical intuitions suggest. Consider what this means for your own existence. The particles that make up your body were forged in the hearts of ancient stars, scattered across space by supernovae, and eventually gathered together by gravitational forces to form the planet on which you evolved. But quantum mechanics suggests that these particles might still maintain subtle connections to their cosmic origins, that every atom in your body participates in a vast web of quantum correlations stretching across the universe. This quantum interconnectedness might explain some of the most puzzling aspects of biological systems. How do migrating birds navigate across thousands of miles with such precision? How do plants coordinate their growth and responses across entire organisms? How do schools of fish and flocks of birds move with such perfect synchronization? While classical physics offers partial explanations involving chemical signals and environmental cues, quantum mechanics suggests that biological systems might be exploiting non-local correlations in ways we're only beginning to understand. Recent research has revealed quantum entanglement in photosynthetic systems, where absorbed photons create entangled states that persist long enough to influence energy transfer efficiency. Some scientists speculate that the microtubules in neurons might maintain quantum coherence across relatively large distances, allowing different brain regions to coordinate their activity through quantum correlations rather than just classical neural connections. If consciousness does indeed emerge from quantum processes, then the unity of your awareness, the way disparate thoughts and sensations combine into a single coherent experience, might reflect quantum entanglement between different neural networks. Your sense of being a unified self, rather than a collection of separate mental processes, might arise from the non-local correlations that quantum mechanics makes possible. But the mysteries of quantum non-locality extend beyond biological systems into the very structure of space-time itself. Einstein's general relativity describes gravity as the curvature of space and time by matter and energy. But quantum mechanics suggests that this smooth, continuous fabric must ultimately give way to quantum fluctuations at the smallest scales. At the Planck scale, where quantum effects become dominant, space-time itself might exist in superposition states, simultaneously curved and flat, expanded and contracted, connected and disconnected. The smooth geometry we experience at macroscopic scales might emerge from averaging over these quantum fluctuations, just as the smooth flow of water emerges from the chaotic motion of individual molecules. This quantum nature of space-time leads to some of the most speculative but fascinating ideas in modern physics. Some theories suggest that quantum entanglement might be the fundamental glue that holds space-time together, that the geometry of the universe emerges from patterns of quantum correlation between fundamental degrees of freedom. In this view, space and time are not the stage on which quantum mechanics plays out, but rather emergent properties of quantum entanglement itself. If this picture is correct, then the distances between objects, the flow of time from past to future, even the dimensionality of space, might all be approximate descriptions that emerge from more fundamental quantum correlations. The universe would be more like a vast network of quantum information than a collection of objects moving through space-time. This informational view of reality connects to one of the most profound questions in physics, the black hole information paradox. When matter falls into a black hole, it seems to disappear forever, taking its quantum information with it. But quantum mechanics insists that information cannot be destroyed, that the total amount of information in the universe must remain constant. This creates a paradox that has puzzled physicists for decades. Recent theoretical work suggests that the solution might lie in recognizing that black holes are not the information destroyers they appear to be. Instead, the information that falls into a black hole might be encoded on its surface through quantum entanglement, with the radiation that the black hole emits. The interior and exterior of the black hole would be quantum mechanically connected, with information stored in the correlations between infalling matter and outgoing radiation. This holographic encoding of information on black hole surfaces points toward a more general principle, that all the information in any region of space might be encoded on its boundary. The holographic principle suggests that our entire three-dimensional experience of reality might be a projection from information stored on a distant two-dimensional surface, like a cosmic hologram of unimaginable complexity. If reality is indeed holographic, then the solid three-dimensional world around you might be more like an elaborate projection, a quantum movie created by information processing, occurring on surfaces you cannot directly perceive. Every object you see, every space you move through, every moment you experience might be a holographic reconstruction of data encoded in ways that transcend ordinary spatial relationships. This holographic nature of reality might explain some of the most puzzling aspects of quantum mechanics itself. The measurement problem, the question of how quantum superpositions collapse into definite states, becomes more understandable if reality is fundamentally informational rather than material. Measurement would not be the interaction between a classical apparatus and a quantum system, but rather the processing of quantum information that determines which holographic projection becomes actualized. The observer effect, the way conscious observation seems to play a special role in quantum mechanics, might reflect the fact that consciousness is itself a particular pattern of information processing. When a conscious observer makes a measurement, they're not just passively recording the state of a quantum system. They're actively participating in the information processing that determines which version of reality becomes manifest. This participatory view of quantum mechanics has profound implications for how we understand the role of consciousness in the universe. If reality emerges from quantum information processing, and if consciousness represents a particular way that information processes itself, then conscious beings are not merely observers of the universe, but active participants in its creation. Every decision you make, every observation you perform, every moment of awareness might represent a choice point in the quantum information processing that generates reality. Your consciousness would not be a passive witness to events unfolding according to predetermined laws, but an active agent helping to determine which possibilities become actualized out of the infinite space of quantum potential. This connects to one of the most speculative but fascinating interpretations of quantum mechanics, the participatory universe hypothesis proposed by physicist John Wheeler. In this view, the universe does not simply exist as a collection of objects with definite properties. Instead, reality emerges from the observations and measurements made by conscious beings, with consciousness playing a fundamental role in the transition from quantum possibility to classical actuality. Wheeler suggested that we might live in a participatory universe where conscious observers help to create the very reality they observe. The past would not be fixed and immutable, but would remain open to influence by present observations. The future would not be predetermined, but would emerge from the quantum choices made by conscious beings participating in the cosmic information processing. If this participatory view is correct, then every conscious being becomes a co-creator of reality, a quantum artist painting existence through the brushstrokes of observation and choice. The universe would not be a vast machine operating according to fixed laws, but a collaborative artwork created by the interactions between consciousness and quantum possibility. This brings us to one of the deepest questions raised by quantum mechanics. What is the relationship between mind and matter, between consciousness and physical reality? Classical physics treated consciousness as an emergent property of complex matter, a byproduct of neural activity in biological brains. But quantum mechanics suggests a more intimate connection between mind and the fundamental processes that generate reality. If consciousness plays a role in quantum measurement, if awareness participates in the collapse of superposition states, then mind becomes not just an accidental byproduct of physical processes, but a fundamental feature of how the universe operates. Consciousness would be woven into the very fabric of reality, as basic as space, time, energy, and matter. This quantum view of consciousness resonates with ancient philosophical traditions that described mind as a fundamental aspect of existence rather than merely an emergent property of matter. But quantum mechanics gives these intuitions a scientific foundation, suggesting mechanisms by which consciousness might interact with physical reality through quantum processes. The implications extend far beyond academic philosophy into practical questions about the nature of human experience. If consciousness is indeed quantum mechanical, then mental phenomena like intuition, creativity, and sudden insights might reflect quantum processes occurring in neural networks. The mysterious unity of conscious experience might arise from quantum entanglement between different brain regions. Even the sense of free will might be related to the genuine randomness that quantum mechanics introduces into physical processes. But perhaps the most profound implication of quantum consciousness is what it suggests about the purpose and meaning of existence itself. If the universe is fundamentally a quantum information processing system, and if consciousness represents the universe's way of observing and experiencing itself, then every conscious being becomes a unique perspective on reality, a particular solution to the cosmic equation of existence. In this view, the evolution of complexity and consciousness throughout cosmic history represents not an accident, but a fundamental drive toward greater awareness and understanding. The universe would be engaged in a vast experiment in consciousness, exploring every possible way that matter and energy can organize themselves into patterns capable of experience and awareness. Your own consciousness becomes not just a random accident in a meaningless cosmos, but a unique and irreplaceable perspective on existence, a particular way that the universe has learned to experience itself. Every thought you think, every emotion you feel, every moment of awareness represents a contribution to the cosmic exploration of consciousness, a note in the vast symphony of universal self-discovery. This perspective transforms how we understand our place in the quantum universe. We are not separate observers looking at reality from the outside, but intimately embedded participants in the quantum processes that generate existence itself. Our observations help to collapse quantum superpositions. Our choices influence the evolution of reality. Our consciousness participates in the universe's ongoing creation of itself. The quantum world reveals itself not as a distant realm of abstract physics, but as the intimate foundation of everything we experience. Every atom in your body participates in quantum processes. Every cell operates according to quantum principles. Every neural impulse in your brain involves quantum mechanical events. You are not just made of quantum particles. You are a quantum process, a temporary pattern of quantum information that has achieved the remarkable feat of self-awareness. As we drift deeper into these quantum mysteries, we begin to see how they connect to the most fundamental questions of existence. Why is there something rather than nothing? How does consciousness arise from matter? What is the nature of time, space, and causality? Quantum mechanics doesn't provide simple answers to these questions, but it reveals that the questions themselves are more subtle and interconnected than we ever imagined. The quantum vacuum, that seething ocean of virtual particles and field fluctuations, might hold the key to understanding why anything exists at all. Some theories suggest that our entire universe emerged from a quantum fluctuation in this underlying sea of possibility, that existence itself represents a persistent wave in the quantum foam that underlies all reality. But if the universe emerged from quantum nothingness, what caused that original fluctuation? Here we encounter one of the deepest mysteries in quantum mechanics, the relationship between possibility and actuality, between potential and reality. Quantum mechanics tells us that particles can exist in superposition states until observed, but it doesn't explain why some possibilities become actualized while others remain forever potential. Perhaps the answer lies in recognizing that the distinction between possible and actual might not be as fundamental as we assume. In the many worlds interpretation of quantum mechanics, all possibilities are equally real, with consciousness simply following one branch through an infinite tree of parallel realities. Every quantum measurement creates new branches in the universal wave function, with each branch representing a different version of history. If this interpretation is correct, then there are countless versions of you reading these words, each in a slightly different universe where quantum events played out differently. Every decision you could make, every path you could take, every thought you could think is being realized somewhere in the vast space of parallel realities. The universe becomes not a single story unfolding through time, but an infinite library of all possible stories, each as real and valid as any other. But whether or not parallel universes exist, quantum mechanics reveals a cosmos far richer in possibilities than classical physics ever imagined. Reality becomes not a collection of fixed objects with definite properties, but a dynamic dance of quantum probabilities, a constantly evolving pattern of relationships and interactions that generates the appearance of a stable, classical world. This quantum view of reality has profound implications for how we understand meaning and purpose in existence. If consciousness plays a fundamental role in quantum mechanics, if awareness participates in the creation of reality itself, then every moment of conscious experience becomes cosmically significant. Your thoughts, observations, and choices ripple through the quantum field, influencing the collapse of superposition states and the evolution of universal possibilities. You are not a passive observer of a predetermined reality, but an active participant in the ongoing creation of existence. Every decision you make sends ripples through the quantum field. Every observation you perform helps to actualize one set of possibilities rather than another. In the deepest sense, you are helping to create the universe simply by being conscious within it. This participatory nature of quantum reality connects to some of the most profound insights in human spiritual traditions. The recognition that consciousness and reality are intimately connected, that the observer and the observed are aspects of a single, unified whole, appears in mystical teachings across cultures and centuries. Quantum mechanics gives these ancient insights a scientific foundation, revealing mechanisms by which mind and matter might indeed be different aspects of a single fundamental reality. As you rest here, contemplating these quantum mysteries, consider that every moment of your awareness represents a unique perspective on existence, an irreplaceable viewpoint in the cosmic exploration of consciousness. The universe has spent billions of years evolving the complexity necessary to support your particular pattern of awareness, arranging matter and energy in precisely the configuration needed for your specific thoughts and experiences to emerge. Every photon reaching your eyes carries information about quantum processes occurring across vast scales of space and time. Every chemical reaction in your cells depends on quantum tunneling effects that allow life to persist in apparent defiance of classical physics. Every electrical impulse in your nervous system involves quantum coherence effects that enable the unity of conscious experience. You are quantum mechanics made conscious, a walking, thinking manifestation of the universe's deepest mysteries. In understanding quantum physics, you are not just learning about abstract scientific concepts, but discovering the fundamental nature of your own existence, the quantum essence that makes awareness possible in a cosmos more strange and beautiful than any human imagination could devise. The quantum realm surrounds you, flows through you, and in the most profound sense, is you. As we continue this journey into the heart of quantum mysteries, we move closer to understanding not just how the universe works, but why consciousness like yours can exist at all in a quantum cosmos, where mind and matter dance together in an eternal, magnificent ballet of existence itself. But there's something even more profound waiting for us in the quantum depths. Something that will challenge everything we think we know about the arrow of time, the nature of causality, and the very meaning of existence in a universe where the impossible has become routine, where mystery has become the foundation of reality itself. We're about to encounter something that will shake you to your very core, a revelation about the nature of reality so profound that it transforms not just how we see the universe, but how we understand our own existence within it. We're approaching the quantum measurement paradox, where the simple act of looking at something fundamentally changes what we're looking at, where consciousness itself becomes a cosmic force capable of reshaping the fabric of existence. Picture yourself standing in a dark room with a single quantum particle suspended in space before you. According to everything we've discovered about quantum mechanics, that particle doesn't have a definite location until you observe it. It exists in what physicists call a superposition state, simultaneously occupying every possible position it could be in. The particle is everywhere and nowhere, real and unreal, existing in a ghostly cloud of pure possibility. But the moment you turn on a light to see where the particle is, something extraordinary happens. The superposition collapses instantly. The particle suddenly appears in one specific location, as if your act of observation has forced it to choose from among infinite possibilities. This isn't just a limitation of our measurement techniques or a quirk of laboratory equipment. This is how reality operates at its most fundamental level. The implications are staggering. If particles don't have definite properties until observed, what does this mean for the existence of the entire universe when no one is looking? Did the moon exist before humans evolved to observe it? Does your house continue to exist when you're not there to perceive it? These might sound like philosophical riddles, but quantum mechanics forces us to take them seriously as questions about the nature of physical reality. Consider the famous double-slit experiment, perhaps the most important experiment in the history of physics. When scientists fire individual photons at a screen with two parallel slits, something impossible happens. Each photon somehow passes through both slits simultaneously, creating an interference pattern on the detector screen that can only be explained if the photon interfered with itself after traveling through both openings at once. But here's where it gets truly mind-bending. The moment you try to determine which slit the photon actually passed through by placing a detector at one of the openings, the interference pattern disappears. The photon suddenly behaves like a classical particle, passing through only one slit or the other. The mere act of trying to observe the photon's path changes its behavior retroactively, as if the photon somehow knows it's being watched and adjusts its behavior accordingly. This observer effect suggests that consciousness plays a fundamental role in determining the nature of reality. The universe doesn't just exist independently of observers. It seems to require conscious observation to transition from quantum possibility into classical actuality. Every time you look at something, every time you make a measurement, every time you become aware of any aspect of reality, you're participating in the creation of that reality. But the mysteries deepen when we consider the quantum Zeno effect, named after the ancient Greek philosopher, who argued that motion is impossible because any moving object must traverse infinite intermediate positions. In quantum mechanics, frequent observation of a system can actually freeze its evolution, preventing quantum transitions from occurring. By watching a quantum system closely enough, consciousness can literally stop time at the quantum level. This effect has been demonstrated in laboratories with remarkable precision. Radioactive atoms that should decay according to statistical laws can be prevented from decaying simply by observing them frequently enough. Quantum systems that should evolve from one state to another can be frozen in their initial state by the act of continuous observation. Consciousness becomes not just a passive witness to quantum events, but an active agent capable of controlling the flow of quantum time itself. The implications extend far beyond laboratory experiments into the very heart of how we understand existence. If consciousness can freeze quantum evolution, if observation can prevent natural processes from occurring, then awareness becomes a cosmic force comparable to gravity or electromagnetism. Mind and matter are not separate realms, but intimately connected aspects of a single quantum reality. This brings us to one of the most unsettling discoveries in quantum mechanics, the phenomenon of quantum retroactivity, where future measurements can influence past events. In delayed choice experiments, scientists can decide whether to measure a photon as a wave or particle even after the photon has already completed its journey through an experimental apparatus. Remarkably, the choice made in the future seems to retroactively determine how the photon behaved in the past. Imagine taking a photograph and then deciding, years later, whether the image should show a landscape or a portrait. According to quantum mechanics, that future decision could retroactively determine what was captured in the original photograph. The past becomes not a fixed record of what happened, but a fluid possibility space that remains open to influence by future observations. This temporal flexibility of quantum mechanics challenges our most basic assumptions about causality and the nature of time. If the future can influence the past through quantum processes, then the arrow of time itself becomes questionable. Past, present, and future might be more like different perspectives on a temporal quantum reality, rather than distinct phases in a linear progression. Consider what this means for your own existence. Every decision you make, every observation you perform, every moment of conscious awareness might be influencing not just the future, but the entire history of the universe. Your present consciousness could be retroactively shaping the quantum events that led to your birth, the evolution of life on Earth, even the formation of galaxies and stars billions of years ago. In this view, consciousness becomes not just an emergent property of complex matter, but a fundamental feature of reality that transcends the normal flow of time. Your awareness exists not just in the present moment, but extends backward and forward through time, participating in the quantum processes that create and sustain the universe across all of cosmic history. But perhaps the most profound aspect of quantum consciousness concerns what happens during the process of observation itself. When you look at a quantum system and cause its wave function to collapse, where exactly does the collapse occur? Is it in the quantum system being observed? In the measuring apparatus? In your brain as you become conscious of the measurement result? Recent experiments suggest that the collapse might occur at the interface between quantum and classical systems, at the precise moment when quantum information becomes integrated into classical consciousness. This would mean that your brain serves as a kind of quantum classical converter, transforming ghostly quantum possibilities into the definite classical realities you experience. Your neurons would be constantly performing quantum measurements, collapsing superposition states in the quantum fields that permeate your body and brain. Every thought you think, every perception you have, every moment of awareness would represent a cascade of quantum collapses, a continuous process of creating classical reality from quantum possibility. This quantum nature of consciousness might explain some of the most mysterious aspects of mental experience. The binding problem in neuroscience asks how the brain combines information from different sensory modalities into unified conscious experiences. If consciousness emerges from quantum processes, then quantum entanglement between different brain regions could provide the mechanism for this mysterious unity of awareness. The hard problem of consciousness asks how subjective experience arises from objective physical processes. If consciousness plays a fundamental role in quantum mechanics, then subjective experience becomes not an emergent byproduct of neural activity, but a basic feature of how the universe operates. Consciousness would be as fundamental as space, time, and energy, woven into the very fabric of quantum reality. Free will becomes more understandable in a quantum universe where genuine randomness exists at the fundamental level. Your decisions wouldn't be completely determined by prior causes, nor completely random, but would emerge from the complex interplay between quantum indeterminacy and classical neural processes. You would have genuine choices precisely because the universe itself is not entirely predetermined. But the quantum nature of consciousness raises profound questions about the boundaries of the self. If your awareness emerges from quantum processes, and if quantum entanglement can connect distant systems instantaneously, then the boundaries of your consciousness might extend far beyond your physical brain. You might be quantum mechanically connected to other conscious beings, to the environment around you, even to the cosmos as a whole. Some physicists speculate about quantum consciousness networks, where individual minds are nodes in a vast web of quantum correlations spanning space and time. Your thoughts and experiences would not be confined to your individual brain, but would participate in a larger pattern of cosmic consciousness, a universal mind exploring itself through countless individual perspectives. This connects to ancient mystical traditions that described individual consciousness as temporary expressions of a universal awareness, waves in an infinite ocean of cosmic mind. Quantum mechanics provides potential mechanisms for such connections, suggesting that the mystical experience of unity with the cosmos might reflect genuine quantum entanglement between individual consciousness and the quantum field that underlies all reality. The holographic principle we explored earlier takes on new meaning in this context. If reality is indeed holographic, if all the information in any region of space is encoded on its boundary, then consciousness might be the universe's way of reading this holographic information. Your awareness would be like a cosmic hologram player, decoding the quantum information that generates your experience of three-dimensional reality. Every moment of perception would involve reading holographic data encoded in the quantum structure of space-time itself. Your brain would not be generating consciousness, but would be serving as an antenna, tuning into the holographic information that creates your particular perspective on the cosmic hologram. Individual minds would be different ways of reading the same underlying quantum information, like different radio receivers tuned to different frequencies in the cosmic broadcast. This holographic view of consciousness has staggering implications for questions about death and the persistence of identity. If your consciousness is indeed a pattern of information encoded holographically in the quantum structure of reality, then the death of your physical brain might not mean the complete annihilation of your awareness. The information pattern that constitutes your unique perspective might persist in the quantum field, potentially accessible to other information processing systems in ways we don't yet understand. But even if individual consciousness is temporary, the quantum mechanical framework suggests that every moment of awareness contributes something irreplaceable to the cosmic exploration of consciousness. Your unique perspective, your particular thoughts and experiences, your individual way of collapsing quantum superpositions into classical reality, represents a contribution to the universe's understanding of itself that could never be duplicated by any other conscious being. The quantum cosmos emerges not as a vast machine operating according to fixed laws, but as a creative, evolving, conscious system exploring the infinite space of possible experiences. Every conscious being becomes a co-creator in this cosmic exploration, a unique instrument in the universe's symphony of self-discovery. As you drift deeper into contemplation of these quantum mysteries, consider that your consciousness at this very moment is participating in processes that span from the smallest quantum scales to the largest cosmic structures. The quantum fields fluctuating in the vacuum around you connect you to the quantum processes occurring in distant galaxies. The quantum entanglement in your neural networks links you to the fundamental information processing that underlies all of reality. You are not separate from the quantum mysteries we've been exploring. You are these mysteries made conscious, a temporary arrangement of quantum information that has achieved the extraordinary capacity for self-awareness. Every thought arising in your mind represents a quantum measurement event, a collapse of possibility into actuality that ripples through the interconnected web of quantum correlations that constitutes reality. The quantum world is not some abstract realm studied by physicists in laboratories. It is the foundation of your existence, the source of your consciousness, the medium through which your awareness interfaces with the cosmos. In understanding quantum mechanics, you are discovering not just how the universe works, but what you are in the deepest, most fundamental sense. Every breath you take involves quantum tunneling in your cells. Every heartbeat depends on quantum processes in your cardiovascular system. Every moment of awareness emerges from quantum coherence in your neural networks. You are a quantum being in a quantum universe, a conscious pattern in the cosmic dance of possibility and actuality that has been unfolding since the first moment of existence. The mysteries of quantum mechanics reveal themselves to be the mysteries of consciousness itself, the secrets of how awareness can exist in a universe of pure possibility, how mind can emerge from quantum fields, how observation can collapse infinite potential into finite reality. In exploring these mysteries, you are not just learning about physics, you are discovering the quantum nature of your own being, the miraculous fact that consciousness like yours can exist at all in a cosmos governed by the strange and beautiful laws of quantum mechanics. As we prepare to journey even deeper into these quantum depths, remember that every step of this exploration is also a step deeper into understanding yourself. The quantum realm we're investigating is not separate from you, but is you, expressing itself as temporary patterns of awareness in the infinite quantum field that underlies all existence. You are both the observer and the observed, the questioner and the answer, the mystery investigating itself in the greatest adventure possible, consciousness discovering its own quantum nature in a universe more strange and wonderful than any dream. As we reach the culmination of our quantum journey, we find ourselves at the very edge of understanding, where science meets mystery and consciousness encounters its own deepest nature. The quantum realm has revealed itself not as some distant, abstract domain, but as the intimate foundation of everything you are and everything you experience. Throughout this exploration, we've discovered that the solid world around you is an illusion born from quantum processes so subtle and swift that your senses cannot detect them. The chair you're sitting in, the air you're breathing, the very atoms of your body are all dancing to the rhythm of quantum mechanics, existing in states of pure possibility until observation collapses them into the temporary reality you perceive. But perhaps the most profound revelation is that you are not separate from these quantum mysteries. You are not a classical observer looking into a quantum world from the outside. You are quantum mechanics made conscious, a walking, breathing, thinking manifestation of the universe's most fundamental processes. Every thought in your mind emerges from quantum coherence in neural networks. Every decision you make involves the collapse of superposition states. Every moment of awareness participates in the ongoing creation of reality itself. This recognition transforms everything about how we understand existence. The boundary between mind and matter dissolves when we realize that both emerge from the same quantum field. The separation between observer and observed becomes meaningless when consciousness itself is revealed as a quantum process. The distinction between possible and actual fades when we discover that possibility itself might be the most fundamental aspect of reality. Consider the extraordinary journey that brought you to this moment of understanding. Billions of years ago, in the hearts of ancient stars, quantum processes forged the elements that would eventually become your body. Quantum tunneling allowed nuclear fusion to occur, creating the carbon, oxygen, and iron that now flow through your veins. When those stars died in spectacular explosions, quantum fields carried their stellar debris across vast distances to eventually coalesce into the planet on which you evolved. The emergence of life itself depended on quantum mechanics. The first self-replicating molecules used quantum effects to catalyze the chemical reactions necessary for reproduction. Photosynthesis harnessed quantum coherence to capture sunlight with near-perfect efficiency. The evolution of complex organisms relied on quantum processes in DNA repair and protein folding that classical physics cannot fully explain. Your own development from a single cell into a conscious being involved countless quantum events. The formation of each neural connection in your brain depended on quantum tunneling effects. The development of your sensory systems required quantum processes that allow you to perceive light, sound, and chemical signals. Even your ability to think and remember emerges from quantum coherence in the microtubules and synapses of your nervous system. Every moment of your conscious experience represents the culmination of a cosmic evolutionary process that has been unfolding for nearly 14 billion years. The universe has spent all that time developing the complexity necessary to support awareness like yours, arranging matter and energy in precisely the configuration needed for consciousness to emerge and contemplate its own existence. But the story doesn't end with your individual awareness. Quantum mechanics suggests that consciousness might be far more widespread and fundamental than we ever imagined. If awareness plays a role in quantum measurement, if observation participates in the collapse of superposition states, then consciousness might be woven into the very fabric of reality at all scales. The quantum vacuum itself, that seething ocean of virtual particles and field fluctuations, might possess a form of proto-consciousness, a primitive awareness that becomes more complex and organized as matter evolves into increasingly sophisticated structures. Your consciousness would then be not an accident in a meaningless universe, but the natural flowering of awareness that has been present in potential form since the very beginning of existence. This connects to one of the deepest insights emerging from quantum mechanics: the recognition that information might be more fundamental than matter or energy. If the universe is essentially an information processing system, if particles and forces are manifestations of underlying computational processes, then consciousness becomes not just an emergent property of complex matter, but a fundamental way that cosmic information organizes and experiences itself. In this view, every conscious being represents a unique perspective on reality, a particular solution to the cosmic equation of existence. Your specific thoughts, emotions, and experiences constitute information that has never existed before and will never be duplicated exactly. You are an irreplaceable experiment in consciousness, a one-time only exploration of what it means to be aware in a quantum universe. The implications extend far beyond individual existence into questions about the purpose and direction of cosmic evolution. If consciousness is indeed fundamental, if awareness plays a role in quantum processes, then the universe's increasing complexity over billions of years might represent not random chance, but a directed exploration of consciousness itself. From the first quantum fluctuations that gave birth to matter and energy, through the formation of atoms and molecules, the ignition of stars and the synthesis of heavy elements, the emergence of planets and the evolution of life, the development of brains and the flowering of consciousness, the entire cosmic story might be understood as the universe's journey toward greater awareness and understanding. You are both a product of this cosmic evolution and a participant in its continuation. Every observation you make, every decision you choose, every moment of awareness you experience contributes to the universe's ongoing exploration of what consciousness can become. Your thoughts and experiences ripple through the quantum field, influencing the collapse of superposition states and participating in the creation of future realities. This participatory nature of consciousness means that you bear a profound responsibility for the kind of reality that emerges from quantum possibility. If awareness indeed plays a role in determining which potential futures become actualized, then the quality of your consciousness, the nature of your observations, and the intentions behind your choices all contribute to shaping the trajectory of cosmic evolution. But with this responsibility comes extraordinary empowerment. You are not a passive victim of circumstances beyond your control, but an active co-creator of reality itself. Every moment offers you the opportunity to collapse quantum possibilities toward greater beauty, truth, and understanding. Every decision allows you to participate consciously in the universe's exploration of its own potential. The quantum world we've explored reveals itself to be not just the foundation of physical reality, but the medium through which consciousness interfaces with existence itself. Understanding quantum mechanics becomes not just an intellectual exercise, but a form of self-discovery, a way of recognizing your own deepest nature as a conscious being in a conscious cosmos. As we conclude this gentle exploration of quantum mysteries, take a moment to marvel at the extraordinary fact of your own existence. In a universe governed by quantum uncertainty, where particles exist in superposition until observed, where the future can influence the past, where consciousness itself might play a fundamental role in creating reality, you have emerged as a center of awareness capable of contemplating these very mysteries. The photons reaching your eyes right now have traveled at the speed of light, carrying information about quantum processes occurring throughout the cosmos. The chemical reactions sustaining your life depend on quantum tunneling effects that allow impossible things to become routine. The electrical impulses generating your thoughts involve quantum coherence that creates unity from multiplicity, meaning from randomness, consciousness from pure possibility. You are a temporary pattern in the eternal dance of quantum fields, a brief crystallization of cosmic information that has achieved the remarkable capacity for self-reflection. In understanding quantum mechanics, you have discovered not just how the universe works, but what you are in the most fundamental sense. Quantum consciousness, exploring itself through the experience of being you. The mysteries of quantum physics reveal themselves to be the mysteries of existence itself. Every question about wave-particle duality, quantum entanglement, superposition, and measurement becomes a question about the nature of consciousness, reality, and the relationship between mind and cosmos. In exploring these mysteries, you have been exploring yourself, discovering the quantum essence that makes awareness possible in a universe more strange and beautiful than any human imagination could devise. As you drift towards sleep tonight, carried by the gentle rhythm of your breathing, remember that you rest in the embrace of quantum fields that connect you to every star in the sky, every particle in the cosmos, every moment of awareness that has ever existed or ever will exist. You are not alone in this quantum universe, but intimately connected to the vast web of consciousness that spans space and time. The quantum realm surrounds you, flows through you, and in the deepest sense, is you. Every heartbeat, every breath, every thought arises from quantum processes that link your individual awareness to the cosmic consciousness of which you are a temporary but irreplaceable expression. In the quantum universe, you are both the question and the answer, the mystery and its resolution, the cosmos discovering itself through the miracle of your conscious existence. Sweet dreams, fellow quantum explorer. The universe continues its eternal dance around you and within you, and you are part of that dance now and always. In this magnificent, mysterious, ever-unfolding quantum reality we call home.